Hey, it's Jag. It works.
Yeah.
First of all, the changes, and it's really quite simple. The way the circuit originally was, the feedback loop is fed from the same point as the tone stack. So we have no real decoupling between both of those. So I put a resistor in there just to decouple the tone stack from the negative feedback loop and everything before that. Probably something I could have got away without doing, but I felt that in doing my tests, it did help to sort of reduce even further the interactivity between the tone stack and the negative feedback loop and the resulting output I was getting. This wasn't the big problem with the circuit. We'll get to that in a minute. So here I've added the decoupling resistor, 51K. The biggest issue with this was that I just blindly installed this balance circuit here. Even at the time, I was looking at it going, we're going to have some funny interactions between this and the unbalanced output, and it's going to mess with the impedance of the previous stage. Somebody else mentioned that in a comment and also said the only way this would ever work would be to put a cathode follower or some kind of buffer before the balance circuit. No, you can do that with passive components, and it was my intention to try and keep this build as simple as possible. But for now, I'm taking the balance circuit right out of there because I do agree that some kind of a buffer is going to work better for this balanced output. But for now, I've taken that out. We're just going to use the unbalanced output, which should be fine going into an instrument level input on an interface or a console. Anything with about a 1 meg input impedance should be fine on the other end of this. So there we are, the schematic cleaned up, and this now should work fine. I know it does. I've tested it, but I'm going to show you on the bench what we have happening now. Here is the preamp. I have it turned on. My fingers are not as close to the circuit as they look in the camera, so don't worry about that. Here's that decoupling resistor here. And I have actually, what I've done to eliminate the balanced out circuit is I just cut those wires, disconnected the wiper from the volume pot, and connected a piece of shielded coax, only grounded at this end, just running straight to the output jack. The signal is very stable now. If you recall in the last video, it was jumping up and down and we were having some jitter. There's none of that now. And that's because I have added in this power filtering board here. So what I have is the B plus coming from the boost converter. It goes through a 10K resistor. And then we have a 100 microfarad, 450 volt cap to ground. And we also have a 0.1 microfarad, 630 volt cap to ground in parallel with that. So this cap is functioning as the reservoir, and the other one is taking a lot of that digital hash and just sending it to ground. After that, I have another 10K dropping resistor, and I have a 40 microfarad, 450 volt capacitor just to do some additional smoothing to the power supply. And I also, down under here, I don't know if you can see it, I have a 220K bleeder resistor installed as well. So all of these resistors, 2 watt, 2 watt. The 220K is a 1 watt. It should be a 2 watt. I just didn't have one, and I've been monitoring it. It's not getting super hot, but I will be ordering some 2 watts for that. So here, the output from the boost converter, we got 300.7 volts DC. The boost converter is doing a great job. It has sat exactly there for 3 or 4 hours. I have had this running while I've been doing other things just to sort of burn it in, and it's been at 300.7 volts the whole time. After the first dropping resistor, we are down to 276.6 volts DC. And then after the second dropping resistor at the smoothing capacitor, we're at 252.5 volts DC, and that's what we're sending to the plates of the preamp tubes. So on plate 1 of the preamp tube, we are seeing 170.02 volts DC, and on the plate of V1B, we are seeing 163.45 volts DC. So everything's looking pretty good there. I do have some adjustability with the boost converter. I can bring up the voltage a bit and get the voltage on the plates of the of V1A and V1B a little bit higher. For now, for our testing, this works just fine. So next thing I'll do is I'll show you the scope output and the actions of the controls and what they do to the sine wave. I've set up the preamp up on some blocks and right in front of the oscilloscope. I'm hoping that my ZV1 will give you a good shot of both the control panel and the oscilloscope. We may have some focus issues, but I think we can get around that. So here we have the preamp is on. I've got the gain and volume full up. Treble, mid, and bass are at their midway point of their travel. I'm putting in a 150 millivolt, 100 hertz sine wave. So we'll check the operation of the controls now. So first of all, you can see that the sine wave is nice and stable. It's very clean. I've got the gain and volume full up. We have no distortion thanks to that negative feedback. I'll bring the treble, mid, and bass full up. There is a little interaction between all of the controls. That's to be expected, but we don't have the sort of bizarre behavior I was seeing before. We've got 150 millivolt RMS signal going in, and we're getting 4.2 volts RMS out. Take the treble, mid, and bass back to the middle of their travel. Treble control, if I turn it all the way down, I do get a little bit of an increase in output. As I turn it up, I get a little bit of a decrease, and some interactivity down here is acceptable. The mid control is, as we turn it up, is giving us a little more output. As we turn it down, it takes the signal down a bit. Everything is behaving the way you would expect. So with the mid turned all the way down, we're getting about a 3.7 volt RMS output. With it all the way up, we're getting about a 5.1 volt RMS output. Now, because we're at 100 hertz bass frequencies, we should see the most effect with the bass control. And we do. When I turn it all the way down, we're down to about 2 volts RMS. Turning it all the way up, we're at about 4.3 volts RMS, and we get a little bit of phase shift as well. But this is all to be expected. If we take all of the controls down to 0, so I've got the treble and bass down to 0 right now. We'll leave the gain and volume up full. When I take the mid down, it should flatline the output, and it does. So this is behaving like a pretty classic Fender tone stack. The next thing we'll do is we'll take a look at this with a 1 kilohertz input signal at 150 millivolts. Again, with gain and volume full up, treble, mid, and bass at the midway of their travel, we're getting about 5.2, 5.18 volts RMS out. Turn the bass, it should have very little effect. We're well out of the bass frequencies, and it really doesn't. Again, a little bit of interactivity when it gets to the bottom of its range, but nothing really to speak of. Mid should have some effect. Taking mid down definitely does. It takes us down to a 3.71 volt RMS output. Turning it all the way up takes us to about a 6.4 volt RMS output. Treble should have some effect here as well. So taking it down, yeah, it takes our output level down to about 2.65 volts RMS. Taking it all the way up, we get about a 7.8 volt RMS output signal. With all the controls full up, we're getting about 8.5 volt RMS output. So again, things are working the way they should. We don't have anything dipping in the middle. We don't have things looking like they're working backwards. The final thing I'll show you is we'll take this up to 5 kilohertz, a 5 kilohertz input, and we'll sweep the controls and see what happens there. One thing I know for sure we are going to see is we're going to have a lot more output. When I was looking at this on one of the Fender amps, I was getting more output in the upper mid-range and even the mid-range compared to the low frequencies. We are getting an 8.57 volt RMS output. Turning the bass should have no effect at all here, and it doesn't, not even some frequency or not even some phase shift. So that's good. The bass control shouldn't do anything here. Mid and treble should. Let's take the treble all the way up. We get a little bit of an increase in volume. We go up to about 9.7 volts RMS out. We take the mid all the way down, and we get about 6.99 volts RMS out. We put the mid back in the middle of its range. Treble, we turn all the way up. We get 13.9 volt RMS out. Taking treble all the way down, we drop down to about 2.9 volts RMS out. Once again, we take all the controls down and we get a flat line output. With all controls up, we get a pretty healthy output. We got 14.5 volts RMS out with everything turned up full. And the one thing I will point out is we're getting a nice clean sine wave out. So I'm satisfied that the preamp is working as it should. I might have some tweaking to do in the final version of this, but I'm encouraged and this looks good. I'll move this over into the studio and we'll try some audio tests. Earlier this summer, my brother was up for a visit, and he brought me 2 basses that he built that he isn't using anymore. This really cool PJ bass. I just noticed now it also has a D-tuner, so awesome, 4-string with a D-tuner. And this also has flat wound strings on it, and I'm really digging playing this, this bass. I've done a basic setup for the level. And I'm going to mute the mic, and you'll see me playing with the treble, middle, and bass controls. Might as well show off the other one. It's a 5-string. I really like the bird's eye maple veneer on top. The other one has a bird's eye maple neck, looking really nice too. I'm going to just leave the controls set where they are. Treble, mid, and bass are just straight up, and gain and volume are at about 3 o'clock. I do think it's working out. I do have some redesigning I want to do. Let's head back over to the electronics shop and we'll kind of wrap up and talk about what's going on going forward. I meant to show measuring the waveform before and after the decoupling resistor, the one between the feedback node and the tone stack. When I did that, I had a 30 volt RMS signal before the node, and after the signal I had about a 19 volt RMS signal, so about a 3.5-ish dB loss before and after that. There's still plenty of signal, plenty of headroom going into the tone stack. I didn't mention, but when I was doing the audio tests in the studio, I had the trim very low on the interface, and I had a pad inserted. So there's a very healthy signal still coming out somewhere in the 8.5 to about 14 volt RMS range, depending where we set all the controls. So no problem with output level there. That was just a quick setup, quick test, just to show proof of concept. The big thing to me that I was concerned about doing the audio test was whether I was going to be able to filter out all of that digital switching noise from the switch mode power supply and the boost converter. The amp was dead quiet. When I wasn't playing anything, there was no digital whiny noise. I don't know if you've ever heard that, but if you have, you'd recognize it immediately. There was none of that in the preamp. So this build has taught me a ton. How negative feedback can interact with a tone stack, why impedance matching matters, and even how a transformer can overload a high impedance circuit. It's also shown me the importance of isolating different stages properly. So I have learned a lot from this. The unbalanced output needs a lot more design, a lot more work. Once I took that out, the preamp was behaving like I thought it should. So sometimes the best thing you can do is just step back and learn from what has gone on, and then start over fresh. And that's what I'm going to do. This marks the end of the prototype Bass Pre series, as it will be renamed, but it's not the end of the Tube Bass Pre. Over the next couple of months, I will be redesigning the schematic. I think there are some changes that can be made that will help it sound better sonically as well. And I'm definitely going to put some heavy thought into how I want to implement that balanced output. It will have some form of buffering for sure. You can do it, as I said earlier, with passive components, but it's not really the best way. It's not going to sound the best. So that will be the biggest change to it. So early in the new year, I will start a new series, The Real Deal Tube Bass Pre-Build. Before I start that, I am going to have a good, well-organized plan, not only of the schematic and the layout, but how and what I'm going to shoot. I'm going to order all new parts for this, get all of those in place before I start. Before the soldering iron gets turned on, I'm going to have a plan, a schematic, a layout, and all the parts. It will not be a 20 plus episode long series. I think this is a good series in terms of prototyping, designing, and troubleshooting. So renaming it makes a lot of sense. Between now and the new year, when I pick this up again, what am I going to be doing? In the next couple of weeks, I will be starting a new series. It won't be electronics based, it will be woodworking based, and it will be an instrument, but that's all I'm saying for now. I already have a very good plan together for it. I'm just finishing up some details, some drawings and things for what I need to build to support the actual project itself. Keep an eye on the channel. That will be coming soon. Thanks for sticking with me through this sort of scattered series. I really appreciate all of the people who subscribe to my channel and comment and watch my videos. I've continued to grow my subscribers, so that's awesome. If you've enjoyed this video, please give it a like, subscribe. Come back, hit the bell so that you don't miss the new series when it comes out. Check out my band One Soul Thrust. The links are in the description below as always. And until the next video, we'll see you.